Teaching Programmers with Daniel Markham.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host, and make sure to check out www.azuredevops.show for past episodes and show notes. And I'm excited that lots of people are taking me up on my open invitation to speak virtually at your .NET user group. It's been a lot of fun, schedules filling up. And if you run a .NET user group, I'd love to get on your schedule. And also, if you're tuning in for the first time, this podcast is for developers who are shipping software with Microsoft technologies. My goal is for all development teams to be able to move fast, deliver quality, and run their systems with confidence. This particular show, we had some weird audio problems, and if it doesn't jive, you might just want to skip it and go on to the next episode. I apologize, but I wanted to publish it anyway because Daniel Markham, the guest, is just so phenomenally good and so much experience. And I'm really bummed that the audio recording got messed up, and my microphone sounds absolutely terrible. So I'll leave it up to you whether to listen to the full show or not. Let's get on with it. Our guest today is Daniel Markham, and he's a semioticist logician. That's another word for programmer. And he likes to help people learn to make better tech. He likes to explain why things work and doesn't tell people what to do. He believes that once you know why, you can figure the what out on your own. And he's a technical coach and author of InfoOps 2. And Daniel, welcome to the show. How are you, sir?
Really well. Howdy, ho, Jeffrey. How are you doing today?
I'm great. And I was really glad that Bob Martin kind of introduced us, because you have, just like Bob in the show for listeners, you can go back a couple of shows and interviewed Bob Martin, who's been programming for about 2 or 3 centuries, I guess. And so Daniel, you're kind of in the same camp. But so with the growth of our industry, I've talked about a number of times, so many people have gotten into our industry, which is really great. And we welcome everybody. But when I started, there were a few decades under the industry, but now we have so much more. And it's great to go back and just remember the lessons and where we've come and what's changed and all that. So do you remember why you even got into this field?
I couldn't escape it, Jeffrey. To be honest with you, I tried and tried. It wasn't any good. The industry was growing faster than the people that were able to fill the roles. And, when I started programming, we only had one computer in the high school, and I wrote a game called Kill Roland, which people loved. There's a guy named Roland, people hated. So I wrote a video game for the Commodore PET in 4K. So it was just one computer, it was a very, very rare thing. But then within, 5-6 years, my dentist office had an IBM PC. So it grew so quickly, and there just wasn't anybody there to program the things.
Okay. And what, just kind of rewind us, what decade was that in?
Well, I wrote my first contract program when I was 17. It would be 1982. And on an Apple IIe for a local bookkeeper. I was changing oil, working at the service station, summer job. And this guy comes in and starts talking about how he paid all this money for this computer. It doesn't do anything he wants it to do, and he can't find the software. And I'd written this game at the high school. And so here I am underneath, changing the oil filter, doing all this stuff. And I go, hey, James, I could probably make this computer do, what you want it to. And he said, how much you think that would be? And, here I am, a grease monkey. I'm like, I don't know, $200.
He said, sold.
He sold. Yeah, sure. He was no dummy. I spent about 60, 70, 80 hours in his shop after hours for the next couple of months, learning bookkeeping the hard way. All in Apple II Basic. I learned bookkeeping and the variable names. I think you could have up to 2 characters in your variable names, so that you can imagine what that code looked like when I was done with it.
Up to 2 characters. Yeah. I didn't start that. I didn't start basic till quick basic.
This is I think this was the Microsoft version. The funny thing about that story was I ran into that guy 20 years later, I guess in the late, maybe 15, late 90s, early 2000s. He was still using the program. And I'm like, why? But why? And he's like, well, the thing is people come into my office and a lot of these guys are carpenters and bricklayers and so forth. And they see this textual stuff on the screen and it looks very mainframey and important. And he said, I get more mileage out of showing them that than I would if I'd showed them something they could buy off the shelf.
Yep. No, it's true. I did I did a program for a school district in the late 90s that, like today, somebody contacted me and said, yeah, we're going to start seeing about replacing that. Do you remember anything about it? So if it works, there's plenty of other problems to solve if that's not one of them.
Yeah, one of the things I learned in the last part of my career is how important it is to actually be able to walk away from a piece of code. Well,
talk about that. How do you see that problem manifesting itself today?
Well, I started off doing small mom and pop gigs just like that, a few weeks, maybe a month or two around, and I would do the user manual and the whole thing. And from there, I went into 40-hour-a-week consulting, and the typical thing there was a multi-month project at the time. And as I stayed in the business, the projects just kept getting longer and longer. And then I went into project coaching, and I'd run into these projects that just seemed like they never ended. Mm-hmm. And so, and not only did I run into them, they became more and more frequent, such that I remember one really large company I was at had a 800-person project going on for 3 years. And we seem to be very good at building castles in the sky. We don't seem very good at like building little sand castles by the beach. Maybe sometimes it's all we need.
Yeah. Well, gosh, that I've experienced that too. Whereas somebody hires a programmer and then that programmer builds something, or a group of programmers, and then they end up maintaining the same thing. But you look at the cost of what it's costing, and maintenance should never cost that.
No. One of the things I talk about, and I swear to goodness, I'm not trying to plug my book, but one of the things I talk about that I don't think many people talk about enough is good enough programming. We talk about perfect programming, that TDD, ATDD, clean code, the rest of that. But we don't talk about good enough. And good enough just means it solves a problem, the customer's happy enough, and I never have to come back and touch it again. That's very rare for the commercial industry for whatever reasons.
Well, you've thought about this enough to actually put it into 2 books now. What are the big ideas that were so important that you knew you needed to put them in a book?
Well, I did some technical coaching for a while. Because I'd sort of been a jack of all trades, I ended up doing technical project management, then architecture lead, and then coaching whole projects and groups of projects. So I guess I kind of worked my way out of doing anything useful in my career. And I felt like it was kind of time to do a book report. I've been doing all this work over these years, and I've been observing all this stuff, that before I check out of here, I would like to at least kind of report back on, here's what I saw, here's what I think. You guys may disagree or not, but this is the conclusions I've reached. And the biggest thing I ran to at first when I did the first book was backlogs. And it turned out that backlogs were almost never done well. And so I started in on backlogs, and as I progressed through the first book, I realized that information management in general was an issue, and that a lot of information that should have been in design or other places, people would just kind of stuff it into the backlog because they didn't know what to do with it. Mm-hmm. And so the first book was really about having a small team and building stuff somebody would want. It's called Build Things People Want, or something like that. And I finished that, and my friends went, that's really good. It's great, but we would like to have something more to do with programming directly. So the second book is about you, the programmer, and the code you're working with, and that interaction back and forth, and how to manage the information that both goes in the code and doesn't, and where to put stuff.
Your book also talks about measuring the quality of your work, and I don't see that as a widespread practice.
Yeah, quality's a good topic. The Bobster's got this thing about, I guess, what is it, software craftsmanship or whatever, and I'm a big believer in doing a good job or not doing it. But I think that, to be frank, Bob kind of pissed me off for quite a while. And I think that the problem was he was just so dogmatic about everything thing. And one of the things that kind of got me going was, I know things like TDD work, but why? And I know things like ATD work, but why? And so I had to take things apart to figure out what actual quality meant. And at the end of the day, really, aside from the program being good enough and meeting somebody's needs and you not having to actually go back and maintain it, quality is really how well you can step into that code 1, 2, 10 years later, figure out what's going on and make any changes you need to make without spending, 6 months doing it.
Okay. And that kind of dovetails into the code you can walk away from. Kind of what does it mean to finish and hand it off so that the person operating it doesn't have to produce new releases of it?
Yeah, I think that the thing that the second book really kind of drove in for me, and being a software kind of dorky geek guy, I have to take everything apart, probably too much. But I took apart exactly kind of what happens when you program. And there's human language, which is spoken, not written, by the way. Written language is a whole other subject. Human language is spoken. It's full of ambiguities. I'll say, I'll meet you down the road and we'll work it out. That actually has no real meaning whatsoever. But sometimes it makes sense for you and I. Sometimes it doesn't. So human language is built to be ambiguous. That's how it's designed. But then programming language is a dyadic system, which is much more based on mathematics and category theory. And we tend to try to use our ability to do human language to sort of pound into the computer what we want it to do. And it's that sort of gap between the dyads and the triads, the human language and the computer language, where we run into a lot of problems like, why isn't this variable named correctly? But one of the two biggest problems is cache invalidation and variable naming. So why isn't this variable named correctly is a good one? Why doesn't this API do what I want it to do? There's this whole slew of issues around us confusing human language and computer language.
And how do we fix that?
Well, there's a lot of ways. I think that one of the things I talk about is what I call code cognitive load. And so let's say you walk into a method to maintain it. When you're looking at the symbols, and by symbols I mean plus, minus, variable names, whatever, function names, just chunks of stuff on the IDE. When you look at those little chunks, how much complexity are you looking at versus how much do you think you're looking at? So it may look maybe something like customer account, balance, add 50 or something with all dots, and you may say, well, I'm adding $50 to the customer balance. When in fact maybe you're adding 50 new accounts to something. So the English that we put in our object names or class names can actually mislead us into thinking we understand something that we actually don't. And so to do a good job, we have to look at the code cognitive load. How much English or how much human language are we expecting the maintenance programmer to have in his head and agree with us when he steps into that? If we're expecting a lot of that, then we'd better have a really good team. We'd better kind of be on the same page. If we're expecting some guy to come in a year from now, probably not going to happen. And to fix that, one of the reasons we do TDD, and it's because when we deal in an object-oriented mutable environment, it's never clear exactly what you're doing. And what you learn when you start doing TDD very quickly is that what you think you're doing and what you're actually doing are two different things. And so TDD teaches you to be a very humble programmer. And it should teach you, beyond that, it should teach you that the code itself can mislead you, even if it's well-written code. So it verifies what we want to do using the same system of symbols we've created to do the thing, right? So it sort of does that bridge between human language and computer language by saying, okay, I don't care what customer means. Whatever customer means, it has to pass these tests when it does blah, blah, blah.
You started that by saying that's why we do TDD.
Yes.
I don't have stats on the tip of my tongue, but I don't think the whole industry does TDD yet. So would you kind of talk about what your version of why, like who should be doing TDD and why, and how do you view that as an engineering practice? Well,
I'll just tie it back in with the first story I talked about, kicking around doing stuff in a local area. What I learned pretty quickly kicking around writing code for people just informally was that a lot of times we'd have a disagreement over whether the program worked or not. And so I would say, hey, I heard you. You told me, in fact, you're sitting next to me, and you told me I made the program do this. I'm done. And the person would say, but no, you misunderstood some sort of concept somewhere or another. the only way around that, I went through that like half a dozen times before I figured this out. The only way around that is to put together a list of things that they want to see, tests they want to pass, and then do the work and then show them the tests pass. And even that doesn't work. But what that does is put you sort of in a feedback loop where they go, oh, no, but by blah, 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 actually mean this other thing. And then, okay, we'll do the next round of new tests. And so you do maybe a day or two cycles with a little list of tests, or maybe an hour or two. And over time, you sort of get your language together with the other guy. Yeah, well, I have to keep coming and going, hey.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Now, along with TDD, a chapter in your book is around TDD and infrastructure. And we've talked a lot about infrastructure and managing employments and all that on our podcast. But what's your view of that relationship?
Oh, yeah. Oh, my God. That's there are like 3 or 4 places I would go right now if I were jumping industry. One would probably be cryptocurrency, the ledger stuff. And the other one would be DevOps or DevSecOps, because this is some really cool stuff going on there. So when I started talking, did the first book about managing information, how to manage it. Mm-hmm. And then the second book, there came to me a problem of what to do with information that's not code. A lot of people wanted forms or procedures or blah, blah, blah. And that's kind of bullshit in my opinion, because whenever you do a form or process, people are going to abuse it. But I wanted to come up with some sort of note-taking strategy. So, what's the minimum number? So the problem became, what's the minimum number of keywords I could use to take notes about the problem without having to give people a process? If you want to take notes, take them. Here's some keywords to use. If not, don't take them. I don't care. And I came up with, I don't know, a couple dozen, maybe a dozen different keywords. And then from there, I built a compiler around using these notes. So you could just take a notepad and take your notes while you're talking to the customer. If you want to use these keywords, they go into the analysis compiler, and then they come out with stuff like executable tests and Gherkin. They could come out in a whole bunch of other places that aren't the code itself. And so I wrote, I guess, what would best be described as an analysis compiler. And that's made to work as part of the DevSecOps pipeline, the idea being you would generate documentation and tests and everything else at the same time you would build your code.
Is there a name? So you built a tool. Is there a name for the tool?
Yes, it's on GitHub. It's EasyAM. Version 1 is EasyAM. Version 2 is EA. Version 1 was just for the book, and it's not the greatest thing. Version 2 is much better. I haven't completely finished it. I wrote to the point where I could do Gherkin feature files, a few other things, user story templates if you wanted to do that. And at that point decided that if I wanted to continue doing it, I'd do it. If not, not.
Okay. We'll put a link in the show notes.
Yeah, but it's a command line .NET application, and part of that, at least the Easy EA project, the second one, I had to figure out how to accept streams from the command line because I wanted to work just like it was a Linux tool. So it does. You can send it, just pipe its stuff from wherever you want to, and then pipe its results wherever you'd like to, and it works just fine. Okay.
And when you talk about those keywords, can you give us a quick rundown of what those keywords are and why they simplify the process? Well,
basically there are sort of 4 main buckets of stuff you can talk about when you're talking about building something for somebody. And that's behavior, that's structure, rules or supplementals, kind of the third one. And the fourth one is the meta, which is kind of how we operate together. So taking that aside, because that's sort of project management stuff, there's really behavior, structure, and supplementals. And everything you hear, everything you talk about will go into one of those 3 buckets. And that was kind of they may go into more than one, but so then I just thought, well, wow, when you catch these notes, why don't you just put, behavior and some notes and supplemental and some notes and so forth and so on. And then we have various ways of doing behavior. The easiest way of doing it is a verb noun clause. So reconcile account, bounce checkbook, check loan status. We talk about system behavior from the outside in terms of a verb and noun cluster. And so if you wanted to put titles in, you could just put behavior, and then it's all in Markdown. You could just put them all in like little hyphenated indents, and that would become your high-level user story. So then it's hierarchical, so then you can link back and forth, and one team can work on the other. And then what you could do is actually start putting together quality tests. You would put tests for the analysis in the pipeline the same way you'd put tests for the build or anything else.
Okay. Yeah, that strikes at the heart of a problem that I don't see that our industry has solved yet in the architecture realm, when it's not just requirements analysis or figuring out what you want to do, but what's really necessary in order to achieve the goal and not accidentally add too much scope.
That was one of the things I do want to bring up. When you start talking about for their first book, how to figure out what people want. I mean, the traditional way of doing it, the way I learned coming up, was UML diagrams and various forms of requirement specs or whatever. And I thought about that. It's not that they're wrong. It's just that they're not always needed. And I found that from my own experience working with teams, that whatever was put in a book somewhere, some poor bunch of schmuck somewhere is going to be doing it all the time. And so I figured it was more important for me to sort of teach the decision factor of when or when not to do various pieces of documentation. And then if you want to use diagrams, that's great. But if you don't know when or when not to, you probably shouldn't be using anything at all, really.
Yeah. And certainly we do see that with a lot of small teams that don't write anything down. They just start writing code.
So how do you scale from that, right? How do you scale from, Joe's in the closet coding by himself, don't bother him, but it works fine and he can leave, to we've got 2 people, we've got 4 people, 100 people. And some interesting things happen when you get to be about, between 5 and 20 people. You get this sort of team of teams things going on, which is a third different type of activity.
Right. And I've talked to some CEOs and founders of startup companies that have an idea for a product that's going to require developers, and they say, yeah, we're probably going to have between 20 and 50 programmers. And I'll stop and say, what makes you think that that's an appropriate team size? What are you trying to do? Well, I just haven't seen anything done if I don't have enough programming staff. And so if any of those are listening, what's your view on what should be able to be accomplished at what team size?
I want to try to put this as diplomatically as I can. We do not know the hell how to staff software projects. Not at all. Not even close. I think the worst thing that can happen to a lot of managers is for them to have a successful project. Because when they have a successful project, whatever happened that one project, they're just going to try to retemplate over and over again. So we just don't know how to staff them. I've been in a dozen meetings at least where somebody comes up with a project, there's a pitch, and the next thing was, well, how many people do you think it'll take to do that? As if we had some cookie cutter, like bunch of, gingerbread men in the closet we'd pull out to plug in. That's really the wrong way to scale. It's the wrong way to estimate. You can't just pull stuff out of the air like that because it looked like it was the same as another problem. One of the things I'd hate to get back to the book, but I have to use this as an example. One of the things I did in the book when I started talking about coding, I was like, do you really have a good grasp as an individual programmer of how hard various problems are? And so I'll go through 3 or 4 examples. I do a chess app. I do a project information system. I do a modular blogging system. And all of those are done, just a few hundred lines of code at the most. And they're all things that if I were to describe them to you, say modular blogging system, you might say, well, golly, that's going to be, 3 teams of people, 6 months or whatever. And it's not unreasonable to say that. There's been a lot of different blogging systems that have taken that kind of manpower. But it only took me like a week. So the difference between what we might guesstimate things to be, even as programmers, and what actually is required is just vast. And a little humility probably wouldn't hurt anybody.
Yeah, I've also seen the dynamic, I'm not sure if you have, but that building the first version and getting it to market sometimes can take, I would say, 3 to 13 weeks. And then about 6 months, and certainly later, you go to do a feature and you spend 3 to 13 weeks on a feature. Yeah,
it's that you've broadened our scope a little bit because you're talking about taking like a startup app to market as opposed to just building something that we have a sort of a pre-sold audience for. Whenever you're taking something to market like that, you're doing value discovery, and value discovery is highly interactive.
I used to think that when you're writing a program for people to sell as a startup, that you would go write a program. Matter of fact, I've done that a couple of times and failed miserably. The problem is that the real work in taking a product to market is with the people, not with the code. So you should join yourself at the hip with whoever you're trying to help, and then the code part should just be something that's just pony up. That's ante up money. You should already know that. But we don't. The thing is, we don't see it that way. A friend of mine used to sell stuff into factories, and he said, the thing is, I forgot what he sold. He said, whatever I was selling in the factory, I would go see the shop foreman, and in his office there was this org chart, and in the middle of the org chart was this box with his department and everybody else around it. And I'd go to another department and it would be another org chart with their box in the middle. And so whatever we're doing to us seems to be like the most important thing there is to do. And I think when we start talking about people getting this industry late, I think we're really hurting a lot of new programmers by teaching them in silos instead of trying to teach them in an integrated fashion. We're teaching people, I'll pick on database analysts. We're teaching people to be database analysts. Well, the customer brings you this database requirement, you do these things to the database, and it's that thing with you being in the box in the center of the factory floor thing. And that's just simply no way to actually do the work we're doing. What we should have is the desired behavior pull the expertise out of us, not take our expertise and sort of pound whatever the features are into whatever we want to do.
If you were putting together a programming school, what would the approach be?
I thought about this many times. I think that this is going to sound weird. I think I would start with text processing. I don't care whether it's Emacs, Vim, Notepad, whatever, VS Code, whatever you want to use for an IDE. I think I would really start with shortcuts, slicing and dicing text, moving stuff around, because those skills are the skills that you can then leverage no matter where you're going from there. And then once you've got really the text slicing and dicing stuff going on, then we can start talking about, behavior pulling out structure, which is, and I don't know, I guess probably a fair question would be what the language would be and all that. That's a good one. JavaScript is everywhere. JavaScript is love and goodness and kindness, and everybody loves JavaScript. And dang, it's a heck of a language to try to teach now, especially with all the stuff that's bolted onto it.
Well, I hate JavaScript.
I was saying the same thing in a nicer way.
No. I have programmed with JavaScript since, 1995, and I've never loved it.
Yeah.
It's been there, but I've always, it's like, okay, I got to do something with JavaScript. But if there's a different way to do it where I don't have to use JavaScript, I'm taking that other path.
The thing is that I'm fairly decent at JavaScript. I've done enough websites that, a couple hundred lines of code. Yeah, you have to be good at it. So it's
yeah.
But that's like saying I'm good at kicking my dog around. It's like, yeah, I may be good at it, but that's not something I really want to be good at. That's not it's not a compliment. I don't know how we ended up with JavaScript being the universal language of programming, but I guess that's what it is.
Well, it happened to be the language that was able to find a way to run everywhere before the others did. And I think with the other language, Java kind of went on that mission, but it never quite accomplished it, run everywhere. But now, hey, maybe WebAssembly gives us a, everywhere runtime.
We're just going to do the same thing. No, don't go there. We're going to do the same thing with WebAssembly we did with JavaScript, okay? I think JavaScript, it first was like, remember DHTML? It was like a little toy. Hey, you can move the text box around when they move. It was fun. And then something happened. It just, oh my God, prototypes and all this other stuff. And I think once, and I don't want to pick on Microsoft because I'm a huge F# fan, but I think once you start adding stuff in version after version to try to make everybody happy, you just build a big old steaming pile of crap, really, at the end of the day. It just doesn't get you anywhere.
Yeah.
It's a C++ problem. I love C++. I haven't coded it in, 10 or 20 years. But C++ does so much stuff that the trick isn't programming C++ as much as it is managing the complexity of what you're writing by using various architectural conceits, like we're never going to use STL, or we're only using STL. And so you'll have to come up with a finely tuned list of things you're not going to do if you're going to program in C++. Otherwise, you're going to have a mess.
Mm-hmm.
So JavaScript's the same way. I did this one-page chess app a couple weeks back, and it was fun because I got to play around with some of the functional stuff JavaScript does that I haven't done in a while. And it was a hoot. It was really a hoot. But the problem was, I'm like, okay, you were just asking about teaching programming. Okay, so now we got functional JavaScript. Would you start teaching functional JavaScript? Would you start teaching modules? Would you start teaching just on-click methods? You almost need, if you're going to teach JavaScript, you need some sort of progressive way of adding the complexity they need so they could stop.
Mm-hmm.
I guess maybe TypeScript does that. I know there's a lot of fans of TypeScript.
Well, shoot, yeah, I'd prefer TypeScript over just the vanilla JavaScript, sure. But with so many changes in technology, and you mentioned we're just going to do it all over again, as you know, the cycles never end. What do you see over the next 10 years? I tell you, the things I'm bringing out in the books, I think, are becoming well known now. We're at the point where there's a bunch of old cranky dudes like me complaining about the same old cranky things over and over again. Some people are sick of it, and I get that. I'm with you guys. I think that if there's no meat behind it, it's just a bunch of old cranky dudes. But having said that, there's some truth to this. We really don't need, 47,000 different, for instance, moduling frameworks. And you can tell there's truth to it because what's happening is the browser's eating these other applications. So, I used Vue.js for my modular blocking system. If I had to go back and do it again, I might just use JavaScript. It's looking pretty good. So I think personally that language designers and platform designers are going to have to make a commitment to keep a manageable set of symbols. And that's going to be a number, 50, 100, whatever. Pick a number. I don't care. And that's how many symbols we're actually going to put into our framework or language. And we're not going to go beyond that. And when we reach that limit, we're going to make choices about what's important or not. Because right now, there's just no downside to adding more crap to everything you build. As a matter of fact, the more people you get that like the thing, the more you're likely to add stuff like that. Mm-hmm. So I have a good question. Well, I love WebAssembly is awesome, but what would you use WebAssembly for? Well, in the Microsoft space, WebAssembly is just another host. Right. It's just another runtime. So I take my C# program, and now I can, instead of writing a JavaScript something or other that like does the chessboard in the browser, I can write that chessboard in 100% C# and then run it in WebAssembly, which is the runtime which the browser has. And now I don't have to code in JavaScript. I coded in the language that I was familiar with. And I think all of the main languages are now having a WebAssembly compiler. So all those languages essentially now can run in a browser because there's a WebAssembly host for it.
And you've described kind of the pipeline. I asked what would you use it for, and you described how you would use it. Right? You would code in your normal language and compile it. But what would be the thing that WebAssembly would do that you currently couldn't do, like in TypeScript, for instance, or whatever? The best I could come up with is deploying web pages as applications instead of doing them as part of an app store. That kind of makes sense to me.
Yeah, and furthermore, even digital signage, Fire TV and Roku, they all have now these browsers baked in, but all of them support WebAssembly. It's kind of been in there. And so now you can have digital signage applications written in all kinds of stuff because they can be deployed because the WebAssembly runtime's there. And you've developed it in the language of your choice, really.
It's a cool idea. You were asking me when we first started this, kind of the patterns I've seen over the years. When JavaScript first came out and the blogging engine was Blogger was the big thing from Google.
Yes.
I actually wrote a JavaScript application that would attach into your web page, and when you're reading an article, wherever it was, as long as the owner of the page edited my script tag, it would allow you to vote on his essays. You give 1 to 5 stars. I called it Bat. And it was cross-script site compilation. I was basically pulling a script from one place and running in a second place and doing it. And it was really cool. People loved it. But now, of course, that kind of coolness has been rendered, you don't want to do that. So I feel like we're going to go through this, and I can go back and tell you stories of DBase and some other things like that. But we've been through these cycles of, here's this cool thing. It does all the stuff we want it to do. We start making it do those things. And then the people with the walled gardens are going, no, actually it's a great idea, but we've already solved this problem. You guys, this is not something we want you doing. And sadly, a lot of people will abuse things. I could see, for instance, WebAssembly being used to physically draw Google login pages. And then you could just go back.
I'm no doubt that it will, because they're already doing it with HTML. The scammers are getting so clever. I'm getting text messages from the post office to ask me to check on a package, everything.
Yeah, my car warranty runs out about once every week, and I don't have a car, which is good.
Oh, doesn't it? Oh, gosh, that's right. Good thing they don't know about my moped.
So, yeah, I love WebAssembly. I especially love the idea of doing direct drawing on the canvas. That's some really cool stuff. I've seen some cool applications. I love the idea of using it as a target. It's the sort of the larger business environment that's going to exist in how we can, as programmers, can use the tech to make things people want, instead of just saying, hey, it's a new target for the compilation.
Yeah.
I was looking at Arlians yesterday. I guess you know what Arlians is. Have you heard of that?
Yeah.
Microsoft Research did this, I guess it's a cloud-based deployment. Because in my book, I talk about super compilers and how you can use if your code meets certain standards, you can actually use the concept of compiler to compile to the cloud itself. And somebody said, hey, have you looked at Arlians? And it was kind of neat. Hello World was, 300-400 lines of code, a lot of XML. And I would require some proving to get there, to be excited about it. Microsoft Research did a kick-ass job with F#. They've done some really, really cool stuff that nobody ever used. And that makes me sad. But yeah, you ask about where this is going in 10 or 20 years, and my answer is in general that we are somehow as an industry converging on the same types of problems, and we may be solving them in different ways, but I think it's good that we're recognizing that these are problems.
Yeah. Well, awesome. I really love talking about just software, technology, philosophy, and with the breadth of experience that you have.
We didn't even get to talk about immutable servers or cloud deployment or auto scaling or anything.
There's tons. Yeah. We could go on forever. We'll have to schedule and do a sequel show.
Yeah.
All right. Well, hey, Daniel, I really appreciate the time. Thank you so much for coming on to the Azure DevOps Podcast. I appreciate it.
Jeffrey, it's been good talking to you. Have a good day.
All right. Thanks. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.